Hello, grading students. We are now on the third week of our online discussion in Mathematics 9. How was the first 2 weeks of your online discussion? Are you able to cope up? Have you done all your tasks for each week? I hope you are doing good and keep it up. Let's have a short recap of our lesson last week. We have discussed solving quadratic equation by completing the square and solving quadratic equation by using the quadratic formula. You have been taught about the step-by-step process on how to use the method 3, which is completing the square, and method 4, which is solving quadratic equation by using the quadratic formula. With that, we are now finished with quarter 1, lesson number 1 for Math 9. Please grab your book, first quarter, and open it on page 170. For this week, week number 3, we are going to tackle lesson 2, which is about roots, discriminant, and coefficients. Before we go to our proper lesson, let's talk about the learning competencies and goals you need to achieve at the end of the lesson for this week. So we have here number 1, characterize the roots of a quadratic equation using the discriminant. Number 2, describe the relationship between the coefficients and the roots of a quadratic equation. These two learning competencies are the two goals you need to achieve at the end of the lesson for this week. Let's continue. Coefficients and roots. From the general form of the quadratic equation ax squared plus bx plus c is equals to 0, the numerical coefficients of this quadratic equation are a, b, and c. I am going to repeat it again. This came from our lesson number 1. So, letter A class is the numerical coefficient of the quadratic term. Letter B is the numerical coefficient of the linear term. And C is the constant term. Please remember that one. Here's the formula for finding the two roots of the equation. So, R1 represents the root 1 and R2 represents the root 2. For finding the root 1 class, here is the formula. R1 is equals to negative b plus the square root of b squared minus 4ac divided by 2a. While for finding the root 2, the formula is R2 is equal to negative b minus the square root of b squared minus 4ac divided by 2a. The two formulas for finding the two roots, or root 1 and root 2, are just the same. They just differentiate on the operation between the negative b and the square root. For root 1, we use addition. For root 2, we use subtraction. We can conclude that all quadratic equations have solutions called roots of the quadratic equation. Again, class, we can conclude that all quadratic equations have two solutions called roots of the quadratic equation. The roots of the quadratic equation can be rational, irrational, real, or imaginary numbers. Rational numbers are numbers that includes integers, positive and negative integers, counting numbers or natural numbers, and whole numbers. It also includes fractions, decimal numbers. And the rational numbers, it includes like the value of pi. The value of pi is an irrational numbers. Also under the rational numbers class, it includes the perfect squares. For example, the square root of 9. If you solve the square root of 9, the answer will be 3. So 3 is a whole number, so it is under the rational numbers. Well, the rational numbers, this includes the radicals which are not perfect square. For example, square root of 5, square root of 7, square root of 10. Those are not perfect squares, so they are under irrational numbers. Then the imaginary numbers class are the numbers that doesn't exist in real life. For example, if you are going to find the square root of negative 1, so there's no such thing as square root of negative 1, but for mathematics, there is. So we just use some special characters to represent that it is an imaginary number. So here is the explanation. An imaginary number is denoted as a small letter I, which is equal to the square root of negative 1, and general form, We have here the square root of negative n. The answer will be, it is equal to positive negative I square root of n, which I represents the imaginary number. So here are additional example. For example, we have here the square root of negative 4. So the square root of negative 4 will be, it is equal to positive negative 2i. It means it's just an imaginary number. Square root of negative 25 is equal to positive negative 5i. And lastly, we have here the square root of negative 7 is equals to positive negative I square root of 7. So that's all for the coefficient and roots. So this is the part 1 of lesson 2. It is all about coefficients and roots. Next one, the part 2 will be about discriminants. So the discriminants is a value that help us determine the nature of the roots of the quadratic equation. By just solving one value, we can easily determine the nature of the roots of the quadratic equation. Is it either both of the numbers are rational, irrational, or imaginary? Or both of the numbers equal or unequal? With the help of the discriminant, we can easily identify it. Here is the formula for finding the discriminant. So D represents the discriminant, capital letter D, is equal to B squared minus 4AC. Again, the formula for finding the discriminant is D is equals to B squared minus 4AC. Next, let us study the table below. So in this table class, if you notice, for column 1, we have the given equation. For column 2, we have the coefficients. So the coefficients or the column 2 have been divided into 3 other columns. So the first column under coefficient is the numerical coefficient A. The second one is numerical coefficient B. And the third column is the numerical coefficient C. Then the third column here, the next one is the discriminant. So the discriminant under the discriminant is the formula of finding the discriminant. Then the fourth column is about roots. So the root number 1 and root number 2. So there is a typographical error. This one here class is the R2 or root number 2. So based from the table class, I'm going to explain it one by one. Where in the explanation, we'll focus on what is the effect of the discriminant in finding the roots. With the help of just the discriminant, we can easily identify the nature of the root. So here is the explanation. Here is a summary of how the discriminant can be used to determine the nature of the roots of a quadratic equation. So the first one is, if the discriminant is greater than 0 and a perfect square, the roots are rational and unequal, as in equation 1. So the example of the first situation is the equation number 1. So it is stated here that if the discriminant is greater than 0, so there are two numbers here that are greater than 0, and another condition, it should be a perfect square. So the only one here that is a perfect square is 100. So again, class, before we continue talking about that situation 1, a perfect square is a number wherein it is a result of multiplying two the same numbers. For example, 10 times 10, the answer is 100. So 100 is a perfect square. Another one is 9. 9 is a perfect square. Why? Because it is a result of multiplying two number 3s. So that is an example of a perfect square. So yun nga dito class, si example number 1 is greater than 0 and a perfect square. So it means the roots are rational and unequal, as in equation 1. So rational siya class kasi there are these are examples of an integer, positive and negative integer, and they are unequal. Basta pakitandaan, if the discriminant is greater than 0 and the perfect square, the roots are rational and unequal. Case number 2. If the discriminant is greater than 0 but not a perfect square, the roots are irrational and unequal, as in equation 2. Again, if the discriminant is greater than 0, so 5 is greater than 0, but not a perfect square. So 5 is not a perfect square, the roots are irrational and unequal as in equation 2. When we say again irrational, for example, I told you earlier, the square root of 5 is not a perfect square. So it can be easily identified as an irrational numbers. And unequal. So it is not equal. Why it is not equal? Because the first root is negative 1 plus the square root of 5 divided by 2. Well, the second root is negative 1 minus square root of 5 divided by 2. So, again class, first case number 2, if the discriminant is greater than 0 but not a perfect square, the roots are irrational and unequal. Okay, case number 3, if the discriminant is equal to 0, the roots are rational and equal, or the roots are repeated as in equations 3 and 4. So the equations 3 and 4 are the examples for case number 3. Again, for case number 3, if the discriminant is equal to 0, so let's check. For equation 3, the discriminant is 0. For equation 4, it is the same, 0. So it means pag yung discriminant natin is equal to 0, the roots are rational. So we have here negative 2 and, okay, typographical error again. So negative 2 and negative 2. This is a negative 2 plus hindi ko lang nalagyan ng negative sign. Sorry. So for equation 3, we have here root 1 negative 2 and root 2 negative 2. So it means, for case number 3, it is true that the roots are rational and equal. Or sabi nga dito, repeated. Repeated siya kasi equal siya. Same lang yung number. And for equation 4, we have here the discriminant is 0. The root number 1 is 1. And the root number 2 is 1. So they are both rational and equal. And the last case, we have A. If the discriminant is less than 0, pag yung discriminant natin is a negative number, the roots are imaginary or complex as in equation 5 and 6. So for equation number 5, let's analyze. So the discriminant is negative 3, so it is less than 0. So it means the roots are imaginary. If you notice class, yung example 2, yung roots niya at yung example 5, parang same situation siya. Yung pinagkaiba lang kasi dito class, imaginary yung part na to. So, negative 1 plus I, square root of 3. It means yung dito class, pag hindi pa na-simplify, square root of negative 3 siya. Pero nang sinimplify na natin, naging I, square root of 3. So, these are examples of imaginary numbers. Then, for example number 5, let's check. The discriminant is negative 64. So, negative 64 is less than 0. So, it means the roots are imaginary or complex. So, let's repeat again, class. So, let's start. Feedback ko lang. Ulitan natin, para mas maintindihan nyo. Okay. Erase ko lang. Kasi this part is really important. Okay. Just wait a little bit. Okay, again, here is the table. So, yung table, erase ko lang yung inks. So, we have here again the case number 1. If the discriminant is greater than 0 and a perfect square, the roots are rational and unequal as shown in equation 1. And the second case is, if the discriminant is greater than 0 but not a perfect square, the roots are irrational and unequal as shown in equation 2. Case number 3, if the discriminant is equal to 0, the roots are rational and equal, as shown in example number 3, in equation 3 and 4. And lastly, we have the case number 4. If the discriminant is less than 0, the roots are imaginary or complex, as shown in equation 5 and 6. I hope you understood the different cases wherein si discriminant yung basis for us to easily identify or determine the nature of the roots of a quadratic equation. Please remember this kasi later on there are activities in your book that you need to solve for the discriminant and identify the nature of the roots. So let's continue. So let us study the table below. So in this table class, yung from the past slide, the informations are complete. All the given for the coefficient, discriminant, and roots are all already have been solved. So nag-focus lang tayo talaga doon sa value ni discriminant, ano ba yung effect ni discriminant sa nature ng roots. But for now, we are going to look for the coefficient, solve for the discriminant and the root. So here is the step-by-step process. So you can take notes for the step-by-step process, ilista nyo siya, or pwedeng makinig na lang kayo ng maayos, or i-view nyo na lang ulit yung video kung sakaling makalimutan nyo. Okay, first one, the step number 1, we're going to find the discriminant. Pero bago mahanap si discriminant, kailangan muna nating i-identify si coefficient. So, for finding the coefficient class and solving the discriminant, sa isang step lang, makukuha natin yung values ng A, B, C, and the value of the discriminant. So, here's the process. First, let's copy the given. And if the given class is not on its general form of the quadratic equation, we need to transform or change it. Again, class, pag hindi pa siya nasa general form, kailangan natin siyang gawing quadratic equation na nasa general form. Pero for example number 1, nasa general form siya. So, una natin gagawin is to identify the coefficients. So, for letter A, again, class, the numerical coefficient A can be found beside the quadratic term or included siya sa quadratic term. So, the quadratic term here is x squared. So, it means the value of A is equals to 1. Then, the letter B is included siya kay linear term. So, the linear term here is negative 3x. So, B is equals to negative 3. Then, for the constant term, so, negative 4. So, C is equals to negative 4. After class sa pag-solve yan, isulat na natin siya dito sa ating table. So, A is equals to 1, B is equals to negative 3, and C is equals to negative 4. Then after that one, we are going now to look for the discriminant. Kasi for solving the discriminant class, we need to use the values of the coefficient. So, based from the formula again, here's the formula. Discriminant is equals to B squared minus 4AC. Without the value of the numerical coefficient of the quadratic equation, the value of A, B, and C, hindi natin magagamit yung formula ni discriminant. Dahil nakuha na natin nga yung values ng A, B, C, we are just going to substitute the values to the formula. So, it will turn into discriminant or D is equals to negative 3 squared minus 4 times 1 times negative 4. So, negative 3 squared, the answer is positive 9. Then negative 4 times 1, the answer is negative 4. Negative 4 times negative 4, the answer is positive 16. That's why in the next time of our solution, it will be D is equals to 9 plus 16. Then add the two numbers, so the discriminant is equals to 25. So after finding the discriminant, let's write it here in the table. So the discriminant is equals to 25. Also, we can make a conclusion here under the discriminant. Since the discriminant 25 is greater than 0 and is a perfect square, then the equation x squared minus 3x minus 4 is equal to 0 has two rational and unequal roots. By just finding the discriminant, we can make some predictions on, or not just predictions, but a claim. What will be the nature of the two roots that we are going to solve later? Again, sabi dito, since the discriminant 25 is greater than 0 and is a perfect square, then the equation x squared minus 3x minus 4 is equal to 0 has two rational and unequal roots. So let's check, totoo ba talaga yan? So magsosolve na tayo for the roots. Again, class, type, hindi ko na-edit. So R2 yan dyan, class, sa R2. Or root number 2. So, find the roots R1 and R2. First, we are going to look for the root number 1. So, which values we are going to use to find the roots? So, we just only need to use, again, the coefficients, the values of A, B, and C. So, substitute the value of A, B, and C in the formula. So, R1 is equals to negative times negative 3 plus the square root of negative 3 squared minus 4 times 1 times negative 4 divided by 2 times 1. Then after that one, let's solve first the negative b, or negative times negative 3. So the answer will be positive 3. Then copy the addition, then write the square root, then solve the terms inside the square root. So we have here negative 3 squared, the answer is 9. Negative 4 times 1, the answer is positive, negative 4 times negative 4, the answer is positive 16. That's why square root of 9 plus 16. Then for the divisor, let's multiply 2 times 1, the answer is 2. Then after that, we are going to simplify the values or solve the values inside the square root. So 9 plus 16, the answer is 25. Then find the square root of 25. So the answer is 5. So root number 1 is equals to 3 plus 5 divided by 2. So 3 plus 5, the answer is 8. 8 divided by 2. So the first root or root number 1 or R1 is equals to 4. So we already had the value of the first root. So isulat na natin dyan siya sa table. Then after that one, let's look for the root number 2. So root number 2 is equals to negative b minus the square root of b squared minus 4ac divided by 2a. And the same step, substitute the value of abc to the formula of finding the second root. So R2 is equals to negative times negative 3 minus the square root of negative 3 squared minus 4 times 1 times negative 4 divided by 2 times 1. So R squared is equals to 3 minus square root of 9 plus 16 divided by 2. Then find this, add the two numbers, so the same answer, square root of 25. So 3 minus square root of 25 divided by 2. Find the square root of 25, so the answer will be 5. Kaya yung kalabasan dito, R squared, R2, is equals to 3 minus 5 divided by 2. So 3 minus 5, the answer is negative 2. Negative 2 divided by 2, the answer is R2 is equals to negative 1, or the second root is equals to negative 1. Then write it here on the table. Balik muna tayo. So let's check class kung totoo ba yung predict natin kanina or yung tinuro kanina regarding sa different cases. So yung case natin dito is the case number 1. So 25 class is a perfect square and greater than 0. So let's check nga yung roots kung totoo bang rational number siya at unequal. So we have here root number 1, 4. 4 is irrational numbers. Then root number 2 is negative 1. Negative 1 is irrational numbers. 4 and negative 1 are unequal. So it means true talaga siya yung case 1 na tinuro ko kanina. So let's try another example. Okay, for equation number 2 plus, again, we're going to look for the coefficients, the discriminant, and the roots. So to solve the equation 2, first we are going to change it into general form. Bakit ba kailangan? Kasi class, yung ating equation is nasa standard form siya na ax squared plus bx is equals to c. So yung gagawin lang dito para maging general form siya, we just need to transpose negative 2 to the left side of the equal side. So yung kalabasan niya will be 5x squared minus 3x plus 2 is equal to 0. Then let's look for the value of ABC. So the quadratic term here is 5x squared. So it means the value of A is positive 5. The linear term here is negative 3x. So the value of B is negative 3. And the constant is 2. So C is equals to 2. Then write it here on your table. Okay, after finding the coefficient, we are now allowed to find the discriminant. So the formula, after copying the formula, substitute the values. So D is equals to negative 3 squared minus 4 times 5 times 2. Then negative 3 squared, the answer is 9. Then negative 4 times 5, the answer is negative 20. Negative 20 times positive 2, the answer is negative 40. That's why ang susunod is D is equals to 9 minus 40. Then 9 minus 40, the answer is negative 21. So the discriminant or D is equals to negative 31. So isulat na natin siya sa table. Then here is the conclusion regarding the predicted, let's say the assumed nature of the roots. So since the discriminant is negative 31 is lesser than 0, then the equation 5x squared minus 3x equals to negative 2 has two imaginary roots. So it means yung roots na makukuha natin class are imaginary lang. So let's check kung totoo nga ba. So let's solve for or let's find the roots of the equation R1 and R2. So to find the R1, the same formula from the last example, R1 is equals to negative B plus the square root of B squared minus 4AC divided by 2A. Substitute the value of A, B, and C to the formula. So R1 is equals to negative times negative 3 plus the square root of negative 3 squared minus 4 times 5 times 2 divided by 2 times 5. So negative times negative 3, the answer is positive 3. Copy the plus sign, then the square root, negative 3 squared, the answer is 9. Then negative 4 times 5 is negative 20 times 2, the answer is negative 40. Divided by 2 times 5 equals to 10. The 9 minus 40, the answer is negative 31. So 3 plus the square root of negative 31 divided by 10. So the answer will be R1 is equals to 3 plus I square root of 31 because the square root of negative 31 is an imaginary number. So this is the answer. Okay, to find the root number 2, so the same formula, change the operation addition to subtraction. Then R2 is equals to negative, okay, the same lang siya. Okay, the next one, R2 is equals to 3 minus the square root of negative 31 divided by 10. So it will become R2 is equals to 3 minus I square root of 31 divided by 10. So this is the second root. So it is true that the roots are imaginary, both imaginary numbers. So I only have here in my presentation 2 examples. So the other examples can be found in your books. Again, class, let's remember. The solution set of the quadratic equation contains all the roots of the equation. The roots of a quadratic equation can be rational, irrational, or imaginary numbers. The discriminants of a quadratic equation is used in determining the nature of the roots of a quadratic equation. So here are the cases. For case number 1, if the discriminant is greater than 0 and is a perfect square, then the roots are rational and unequal. If the discriminant is greater than 0 but is not a perfect square, then the roots are irrational and unequal. Case number 3, if b squared minus 4ac or the discriminant is equal to 0, then the roots are rational and equal, or the roots are repeated. And lastly, case number 4, if b squared minus 4ac is less than 0, or the discriminant is less than 0, then the roots are imaginary or complex. Please do remember these 4 cases. And please remember, again, the formula for finding the discriminant is b is equals to b squared minus 4ac. Here is the list of the activity that you need to answer under lesson number 2. So please answer Let's Practice A on page 173. Answer numbers 1 to 5 only. So I would also like to remind you again that the submission will be on October 7 and 8, 2021. Please do organize your outputs by subject. Follow the format of what to be written in your papers before answering and secure it with a staple upon submitting. So thank you for listening, break a leg, and see you next week for an informative and challenging new lesson 3. Goodbye!